Ladies and gentlemen, good afternoon and welcome to another memo discussion for Technical Sciences Grade 11. And the presenter of the day will be Ntate Felix Ntsiye, FTS, all the way from TMED colleagues. He was now the examiner of this paper. I hope our learners performed at the desired level. So without wasting any time, because this is now a 150 mark paper, I just need to check if I'm audible enough and we have an audio maybe coming from your side for the purposes of questions as well. Anyone that feels like saying hi to me, feel free to do so, such that we know that we have proper audio from our side and your side as well. Josephs, maybe.
Good afternoon, Mr. Nambani. Good afternoon, colleagues.
Thank you very much. Ladies and gentlemen, without wasting any time, I believe you can see the screen that I shared. I'll be operating the site and then Ntate will be taking us through. Ntate, the platform is yours.
Thank you, Ntate Nambani. Colleagues, good afternoon. Maybe first I should start by acknowledging the presence of the Chief Director, Ntate Monsus, who is with us, and Director Menel, who is also with us, and also colleagues from district offices and head office. I can see some of them are here, even though maybe I'm not going to mention them by name, all of them, but colleagues, welcome, and also the teachers in all our districts. Welcome to this memo discussions. We will take questions as we proceed for clarity and maybe for coming up with other alternative solutions. But that will be done through Ntate Nambani so that at least we are marking the same and then we have the same understanding. Like Ntate Nambani is indicating from my side, he will be operating. So Ntate Nambani can go to question 1, which is multiple choice. And then we haven't received any this far that maybe there are some questions which are not clear, or maybe where there are some maybe points of not understanding, or maybe where we are not agreeing. So we are going to accept all the items as they are for multiple choice questions. And then if there are any, then we'll take them later. And then we can go to question number 2, which is basically about the vectors. And it is based on forces, the way I've seen it. The question reads thus: there are 3 forces, A, B, and C, with magnitudes of 20 newtons, 25 newtons, and 35 newtons respectively, are acting on an object in the same Cartesian plane. So the figure it is given there, and everyone maybe who's having a question paper in front of him or her can see that. Now the first question: explain why forces are classified as vectors for 2 marks. We accept that it is going to be that because forces have magnitude 1 mark for that and direction for another mark. So it is part marking there. So it is 1 each, direction and magnitude. And then question number 2.2, calculate the magnitude of the resultant force of all the 3 forces for 5 marks. Now for this one, we are having 2 options. I'll start first with option number 1. Now for option number 1, we are looking at, first, we are looking at the options like the angle given. So we are looking at force A, force B, and force C along the X, and then we are going to look also along the Y axis, and then come up with the sum to can go to the resultant. So for option number 1, we are looking at A, and then it is going to be that component which is going to be along the x-axis. So we are looking at cosine of the given angle, which is 30. And then for B, it is the same magnitude of 25, and then the cosine of 40. Now the 40 is coming from those two between the X and the Y. It is 90, so we are giving the 50. nearer to the y component. So we are looking at the x. So that's why we go to that 40. And then we calculated those magnitudes, and then we gave the direction. Though there are no, if you look at that, it is for the whole of that substitutions that we are having the mark. So it is only 1 mark because it is the same scale. We are not going to give more marks for the same scale. And then from there we go to C. If you look at C, it is only along the y-axis, and then there's no component for x, hence it is given a 0 there, and there are no marks there. And then from there, we go to same option 1, we go for the y component. Now, if you go for the y component, then it is going to be a of y, which is going to be 20, and then the sine of the 30 as an angle that is given there. So then we get that magnitude to be 10, and then you go for B. For B, it is going to be the sine of 40, because it is that angle that we have calculated, and then it is going up. And then for C, now your C, it is going down. So both A and B, they were going up, but C, it is going down. Then we have that value of 35 as it is given on the picture. And then for option number 2, what we did, we take then the cofunction of the angle given there. For instance, for A, the cofunction of it is going to be the 60, and then it is still going to be the sine of 60 that we are using there for A, instead of the cosine of 30 for the same magnitude that we are going to get. And then for B also, we are looking at B, and then the sine of 50 as it is given there to go to that, and then we are still going to get the same magnitude that it is going to the left, and the other one is going to the right. So those are the two. And then we do the same for that option number 2 for the y component. So for y component of A, it is going to be the cofunction of that what we have as for A, it is going to be the cosine of that angle 60. And then we get the same magnitude as 10. And then we go for B, which is going to be the same magnitude of 16,07. And then the directions are given. And then can you go a bit up, Ntate Nambani? Now, up to that point, thank you. We add the x components to go to, it is going to be the component of A, the component of B, and then the component of C to get that resultant. And then the direction is going to be the one that is going to be bigger for that. So the learners can take any sign to be positive or negative, accept it, but look at the direction that the direction should be also be correct there. And then downwards as positive, now we are looking at the y component, and then we add all the vectors to can come to 8,893 newtons going down. And then from there, because we are now having the components of the y and the x, it is 1 mark each of them. Now at that point, we are already at 3 marks. And at 4 marks, I think, because it is 1 for the components as we calculated, and then the sum of all this. Now we end up with the x, first x, and then for first y, we end up with the sum. And then from there, we apply the Pythagoras theorem to can go to the component. So we add all this. No, in this case, colleagues, when you read this, depending on what the learners have taken as a direction, the negative and the positive, they can still have negative and negative there. It doesn't matter. Just follow what the learners are trying to do here, even though we give one option, but we can still go for down being negative, and then we can still go for right being negative. So the learners can just decide on whatever they have as a direction, but the answer should be one that it is given because we require them to calculate the magnitude. So it is going to be 9,12 newtons. So that is going to be our 5 marks for that point there. And then question 2.3, calculate the direction of the resultant force calculated in question 2.2. Give direction as a bearing. So in that case, what is it that we are having? We are saying it is going to be positive marking from question 2.2 because we are using the components of y and the x to go to that angle there. So whatever answers that the learners have above, then they can use it here. Now we are at that angle, then we are going to take the tangent, and then we take the reciprocal of the tangent, you can go to that. 1 mark it is on the substitution, colleagues, and then getting to 78,42, and then because we want the bearing, if we look at that angle there of 78.42, then we are going to add it to the 90 to can come up with the resultant. So that part where we are adding the 90 to the 78.42, it is 1 mark, and then the final answer of 168,42, it is going to be another mark for the degree. Or alternatively, the learner can look at it and say, for the same, because it is in the same pattern, instead of adding 90, then you can still go to 180 and subtract. Now, here we are going to take that 11,58. We took it from 90, and then we less the 78,42 to go to 11,58, and then we subtract it from the 180, and then we get the same answer and the same result. So it is going to be 3 marks. Either you add to the 90 or you subtract to the 180, then the answer will be the one that we are taking along. So that will be our 3 marks for that question there. And then still under question number 2, we go to 2.4. It says there, by means of an accurate scale drawing, determine the resultant of forces A and B and use the scale 10 millimeters to be equal to only 4 newtons. So the way it is presented there, you see that newtons of 20, then they will be represented by 200 millimeters. And then the 25 newtons, then it is going to be equal to 25 millimeters. And then the angle between the two, it is the one that it is going to be the 50 and then the 60. So that 110, it's what we need for this. That is the angle between the two forces. And then we end up with that parallelogram there. So the marking criteria, it is what it is given there, that for A, ultimately we are going to have 50 millimeters, and then for B we are going to accept between 62 to 63 millimeters, and then that angle of 110 we have to get it as it is, and then the correct values of the resultant, that is what we are going to take. And then for that resultant we are going to look at the range between 88 to 90 for the accurate scale drawing. So the total for that question, then it is going to be 14 marks. That is about question number 2. I hope I don't see anything. I will proceed and take the questions maybe at the end of each question in case it's not going to delay us. But for clarity, then I will make provision for that. In the absence of any data number, let's go to question number 3. I don't see any hand. I don't see anything on the chat.
Thank you very much, Ntatensi. There's a hand from Comtech.
Okay.
Comtech.
Oh, also, apologies, Mr. Mutolo. Mr. Mutolo, I just typed fast.
Okay,
Apologies.
Mr. Mutolo.
Yes. Greetings to everyone. My question is about 2.4, because the question did not say to use the parallelogram law. I think Elena could have used the tilt-to-head method to find the resultant here. Should Elena be awarded full marks in that case?
If the learner it is using the tilt-to-head method or the so-called triangle method,
yes.
If it is accurate, we are going to accept it.
Thank you very much.
Because it's still going to give us the same result.
Yes. Thank you.
Any other question? I see there's a hand. It's also Comtech, or is it an old hand?
It is an old hand from Comtech and Tate. Thank you very much.
An old hand.
I believe we can proceed to question 3.
Let them lower the hand. Question number 3, it is still about forces and vectors. It says there, the diagram below shows a sketch of 3 forces, F1 equaling to 30 newtons west, F2 equaling to 80 newtons south, and F3 equaling to 40 newtons north, acting on a toolbox resting on the floor. Then the diagram is given, and then 3.1, define the term coplanar vectors. Now the expected answer, which is going to be a 2 or a 0, unfortunately, vectors that are in the same plane for 2 marks. It is going to be a 2 or a 0 there. Thank you, Ntate Nambani, for adding that. And then 3.2, identify 2 forces which are collinear in the diagram. So the forces that are collinear, it is going to be your F3 and your F2. 1 mark for each, and it is 2 marks. And then question 3.3, identify 2 forces which are coplanar in the diagram. Now, in that one, it can be any combination. It can be F2 and F3, or F1 and F3, or it can be F1 and F2, any combination of the two. Then it is going to be marked the same as it is there. Let's accept Ntate Nambani that we gave 1 for each, like in the previous one, not be 2 or 0, like it is indicated in the memo there. And then question 3.4, determine the resultant of the forces F2 and F3. So that one, resultant, it's a vector quantity, so we expect 1 mark for 40 as a final answer, and then it should go down. 1 mark for the magnitude and 1 mark for the direction. 3.5, hence determine the magnitude of the resultant of all the forces acting on the box. So it is going to be positive marking from 3.3. So your resultant, it is going to be forces along the X and forces along the Y. So we use Pythagoras theorem and just substitute the 30 squared, which is going to be along the X, and then the resultant of Y, which is going to be 40, and then you can square it, and then goes to 50. And may I put it there, maybe if the learner, they are just substituting there the direction on the 40 as negative, let's accept it. And also on the 30, if they're taking it, the direction being negative, then the answer, because you need the magnitude is still going to be the same there. So we can take either positive or negative values as been substituted because of the direction that the learners can choose. So that is going to be your 3 marks there. And then 3.6, it says there, if the magnitude of F2 is changed to 40 newtons, what is the magnitude and direction of the resultant of the forces acting on the object? Give a reason for the answer. Now, the resultant of the forces, it is going to be 30 newtons, 1 mark for that, and then the direction goes to the 30. Why is that the case? Is because the resultant along the y-axis, it is equal to 0, or the forces along the y-axis are balanced for the other mark. So the total for that question, it is going to be 14. I think that is that one. Question number 3. Let's take questions if there are any before we proceed. I don't see any hand. I don't see anything. Maybe let's proceed to question number 4. Question number 4. It says there, a block of mass 5 kilogram is connected by means of light inextensible string to another block of 8 kilograms. The 2 blocks are placed on a rough horizontal surface. A force F is applied to the 5 kilogram block at an angle of 25 to the horizontal. The system moves to the right with a constant speed. Then the picture, it is given there, and then from there it says there's a statement there. the force exerted by the surface perpendicular to the surface on the 5 kilogram block, it is 27,87 newtons. 4.1, give the term for the underlined phrase. That underlined phrase, it is indicating a normal force. So force, it is in bracket, then we can still accept if maybe it is a normal there for 1 mark. And then 4.2, draw a labeled free body diagram showing all the forces acting on the 5 kilogram block for 5 marks. Colleagues, can I just before I go, I know there are colleagues also here, our subject advisor colleagues, maybe they should take it along while I'm using this opportunity that the message that we got from DBE when we are attending the memo discussion, from next year, the components of forces are not going to be taken. We are going to take only the forces as they are. So it is a message that we should also carry maybe to our physical sciences colleagues. I'm not sure of the technical sciences, but from next year, the component of forces are not going to be taken. So we are only going to deal with the forces. Now, our expected answer, it is that first one, which is going to be having, we are going to have the normal force pointing up. We are going to have the force applied at an angle. We are having to have the frictional force, which is kinetic to the left, and then we are having a tension also to the left, and then the weight going down. And then we are going to accept whatever it is under that acceptable labels or accepted labels. There is an option before we move on to Tenambani. Let's go to that other option, which is going to be the or. In the or, we are still going to have the normal for 1 mark. We are still having the friction for 1 mark. We are still having the tension for 1 mark. We are still having the weight for 1 mark. And then the components of the force, both the vertical and the horizontal combined, they are going to be given only 1 mark, provided they are both there and then they're in the correct direction for another mark. So the total for that question, it is going to be 5 marks. We can go to question 4.3. 4.3, it says there, calculate 4.31, magnitude of the applied force acting on the 5 kilogram block if the forces along the y-axis are in equilibrium. So in this case, we are looking at the 5 kilogram block, and then we have to look at all the forces that are acting there. Now for the first mark, because they are in equilibrium, then the sum of the forces acting along the y-axis, they must be equal to 0. Or the learners can put it that they are balanced. That is going to be your normal and your Fy, because they're going up, it is equal to the force going down, which is going to be the weight. Anyway, they are putting that formula or maybe that equation, it is going to be 1 mark there. And then the substitution on the left-hand side, that the normal and the force y component, they are equaling to, they are added together in the same direction, 1 mark, and then the weight, calculation of the weight, another 1 mark, and then the total,
And Tatensie, I think we have lost you. Colleagues, can you hear Tatensie?
We can't, many of this side, we can't.
Yeah, let me try and locate him.
Also, we can't hear him from a little side.
Okay, Miraj, maybe you must just rejoin the meeting. It's probably load shedding or something. Colleagues is trying to rejoin, will be with us very soon. Let's just be patient. Thank you very much. While we are waiting, colleagues, just a reminder, please complete the attendance register as the evidence that this actually took place, because I saw yesterday for grade 10 some of you did not complete the register even though you attended the session. Please complete the register while we wait. Thank you very much. Thank you very much, colleagues. Ntatenzi is struggling, so I think for the sake of time, maybe I should also try to continue, but I can see he's now in the meeting. Thank you,
Yeah, but
Ntatenzi.
I'm back. Yeah.
Thank you very much.
Colleagues should understand here in Kot we're having load shedding and power shading, so they must just bear with us, but all is well. Let's proceed. We were at question number, can't even remember. I think we're at question number
431.
4.31. Is it working that?
Yes, 431, Ntatenzi.
431, yes. Yeah, I was saying the statement it is saying the forces are in equilibrium. So we are going to look at the normal and the component of force Y, of force F, the Y component of it. And then for that substitution there, we are going to get 1 mark. And then for the other, it is going to be on the weight, the substitution for that, and then the total for that, it is going to be only 4 marks for that question there. So it is 1 mark for the 4 marks for the formula or the expression, and then 2 marks on the substitution, and the final answer also for 1 mark. And then we move to question 4.32. If we look at 4.32, it says there the magnitude of the kinetic frictional force on the 5 kilogram block, if the kinetic friction between the surface and the 8 kilogram block, it is going to be 41.22 newtons. So we separate it from the rest. So it is going to be positive marking from 431. Now, based on what we have as an information, the most important part that we give a mark, it was for the learners to realize that if we are looking at the 8 kilogram block, the tension force and the friction, they're having the same magnitude. So then we can go and check that the tension in the 8 kilogram block joining the two, it is the same tension. So we are going to use that value there. So we give 1 mark for that part where we are saying the tension, it is actually equal to the frictional force for the 8 kilogram block. And then from there, we go to look at what is it that it is happening. Now, this blocks or this system was moving at a constant speed. Now, based on that, then it is leading us to Newton's first law. And then whatever way that the learners are putting it, that the resultant is equal to 0, or if we are looking at the balance of the two forces, then it is fine. So 1 mark, it is going to be for that expression to looking at Newton's first law in whatever way. So that force Fx, it can be resolved. So for the resolution, there's no mark until we can go to the substitution. So we substitute the 50 and the 25 degrees Celsius, degrees, not Celsius. 1 mark for that, and then the tension plus the friction on the other side, 1 mark also, and then calculating the frictional force to be equal to 4.10 newtons, it is another mark. So the total for that sub question, it is 5, and then the total for the whole question, it is 15 marks there. And for that part of 15, 50 cosine of 25, if the learners are using the co-function, we are going to accept as a sine of 65, I think, here. Yeah. at that point there, we can accept that co-function there of sine of 65 degrees. Then we are going to accept it there. And then let's move on to question number 5. If there are no questions on question number 4, and sorry for the mishap, Comtech, hand it's up.
Yes, greetings again, sir. It's more of a little concern because of we've had challenges with grade 11 because of unavailability of the content guidelines. And this question in particular, it brings up about that concern from constant speed to concluding that the forces are balanced, the net force is 0. It seems like it's referring to Newton's second law, to which it would seem difficult for learners to come to that if you look at grade 11 content there, which my conclusion is feeling like this question was an unfair question if the learners needed to this knowing from constant speed to knowing that the forces are balanced. This is Newton's second law, from which I feel like the learners from grade 11 from their content would not have been able to put that connection together. That's just my opinion. I just want to get clarity on that. Maybe going forward, how would one maybe approach such a thing there? Because it is Newton's second law.
Okay, no, it's fine. But let's look at it this way, maybe. Forces are examples of vectors. And
Yes.
in grade 11 tech science, I think we have this part where we are looking at forces that are in equilibrium, isn't it?
It's true, that's true. Very much true.
Hence, we are looking at that question number 3 is part of the Newton's laws. Question number 2, it is that, and then in one way or another, there is equilibrium. And then to say that they are in equilibrium, I think we are adding all the forces. And then when we add them to be in equilibrium, we know it is going to give us a resultant of 0, isn't it?
That's true.
Not necessarily that I have addressed it using Newton's second law. I'm using it using the vectors as they are prescribed to them. So the question, even though maybe to you it was looking as if it is an unfair question, to me it is still a fair question. It is addressing equilibrium, and then forces being example of vectors. I think we are within what it is prescribed for the grade 11. But I'm not saying it is what I'm thinking, and I don't know what is the take of other colleagues and others in the house, because it is not meeting this our meeting.
Okay, yeah, that's true. That's true. And I see equilibrium of forces being balanced on one side. And if probably the question was indicated that the forces were balanced and the system was at equilibrium, then I would say that learners knowing equilibrium means resultant is 0. But here the indication, the learner was supposed to know that the equilibrium is 0 from constant speed. And constant speed relates to acceleration being 0. And my argument was acceleration being 0, meaning resultant is 0, is relation to Newton's first law. All I'm saying is that my learners from constant speed in capital letters, the deduction that the resultant is 0 is reference to Newton's first law. And hence, I think maybe just going forward, maybe one should try to include such matters in doing the topics. I feel that way.
No, your point is well taken, and then we will look into it. Thank you, Bob.
Thank you, sir.
Okay. Any other concession, or maybe any other contribution, or maybe should we proceed? But your point is well taken, Bob. We will look into it.
Thank you, sir.
Okay, now let's move to question number 5. Question number 5, it's all about waves. And it says there, the graphical representation of a wave generated in a string over a period of time is shown below. The speed of wave generated is 10 meters per second. And then it is given to us graphically there. And then we are having the y displacement, and then we are having the time. And then 5.1.1, what is the amplitude of this wave? The amplitude of this wave, it can be given as it is as 20 centimeters, or the learners, they can convert it to meters to be 0.2 meters, and then 1 mark for that. And then 5.1.2, define the time frequency of a wave. It is number of complete waves per second, or just the number of waves per second. Complete, it is in bracket. So for that one also, according to the memo, we cannot just maybe go for part marking. It is 2 or a 0 for that one there. And then from the graph also, let's look at it. It is, what is the period for this wave? So the time taken to complete that one wave, it is equaling to only 2 seconds. 1 mark for that. And then 5.1.4, define the term trough. Trough, the way it is in the examination guideline, or the way it was given, it is the lowermost point in a transverse wave. There is no way that can be omitted there. Maybe we can put that transverse maybe in bracket that number to just give maybe some sort of an understanding better. Trough will always be on wave, not necessarily only on that one, but it is fine. And then 5.1.5, calculate the wavelength of this wave. 2 options are given. We are given the speed, and then we are given the period to complete one wave. So we can use that first option, that speed, it is equal to wave length divided by period. The speed, it is 10, and then the period, it is 2. So from there in 5.1.2, I think it could be, 2, and then is going to go to wavelength of 20 meters. And then option number 2, it is using the wave equation. V, it is equal to lambda multiplied by the frequency. And then the speed, it is 10. The frequency, it is equal to 0.5. And then it is given as the wavelength of 20. So total for that, it is also 4. 1 mark for the formula, 2 marks on the substitutions, and then final answer in meters of 20, 4 marks for that one there. And then let's go to question 5.2. 5.2, it says there, a wave is produced by a tuning fork. Should have been waves, ne? Has a frequency, or a wave, should have been a wave, frequency of 2.56 hertz. The waves produced are represented by the diagram below. So we have that one, and then it is labeled 5.2.1, name and define the kind of wave given in the diagram. So 1 mark for saying it is a longitudinal wave. Wave, it is in bracket because already it says it is in the question that should be waves are already there. And then why is that the case is because the particles of the medium vibrate parallel to the direction of propagation of the wave for 2 marks. So the total for that, it is 3 marks. So 1 mark, it is basically on identifying it as a longitudinal wave. And then the second mark, it is looking at the particles in the media being parallel to the direction of propagation for another mark there. Please, colleagues, there is no negative marking for that one. Let's just not restricted to positive marking, so part marking of some sort, it is given there. And then 5.2, name parts labeled A and B. Our A, it is a compression, and then B, it is going to be a rarefaction. 1 mark each for 2 marks. And then 5.2.3, what is the wavelength of this wave? So the wave of this, it is given there as 266, but it is between two waves that are there. So divide by 2 and then convert it to meters to be 1,33 meters there. And then 5.2.4, calculate the speed of this wave. Now the speed, it is going to be formula of the wave, which is the equation formula, V equal to lambda multiplied by frequency. And then it is going to be the one that was set, which is asked in 5.23, which is 1,33, multiplied by the given frequency of 2,56 hertz. And then the final answer equaling to 340.48 meters per second for 3 marks. And then 5.25, write down 2 letters that represent points in phase. The ones that are in phase, it is only B and C for 1 mark. And then 5.26, calculate the period of this. Now the period is going to be T equaling to 1 over frequency. And then for one wave that we have, the frequency is equaling to 2,56, and then the answer of 0,004 seconds. Colleagues, this part, that one, is not necessarily the reciprocal. It is just indicating the wave, number of waves which are there. It is only one for each frequency given there. So it is not the reciprocal per se. So that is equaling to 24 marks for that question number 5. Question number 6, it is dealing with sound. And then it says there, a sound source, a sound wave is produced by a source placed a certain distance from the cliff of a high mountain. The echo reaches the source after 3 seconds. Okay, there is a hand, Comtech, sorry.
Dimalang, 5.2.3, they wanted the wavelength there. I was asking if maybe is it possible that we can have a positive marking between 5.2.3 and 5.2.4?
Yes, we can.
Okay, thank you very much, Nade.
Okay, that's fine. Yeah. Any other colleagues? No other, that number.
Continue, Tapi.
Okay. So we are at question number 6. A sound wave is produced by a source placed at a certain distance from a cliff of a high mountain. The echo reaches the source after 3 seconds. Then it is given there's a picture, and then 6.1.1 define the term echo. And then the echo, it is the reflection of sound waves. 2 marks or 0. Reflection of sound waves. And then 6.1.2 are sound waves, transverse or longitudinal. They are longitudinal waves. So waves can be in bracket, it is fine. Longitudinal will be fine. And then 6.2, define reflection of sound waves. Reflection means it is the bouncing back of the wave from the surface. So 2 marks for that one, bouncing back of the wave. So there is nothing that we can say maybe part marking about it, colleagues. It is just going to be the way it is. And then 6.3, define the term pitch. Pitch is a measure of high or low a note is. 2 marks or 0, unfortunately. And then 6.4, consider the 3 diagrams below that illustrate the different sound waves on an oscilloscope. So importantly about it is the time taken there. It is 1 second each, and then the amplitude are the ones that are different, and the number of waves are what it is different. So identify the diagram that would be obtained for 641 soft sound, and we explain. So for soft sound, it is diagram 3. And then the reason it is having a lower amplitude. So 2 marks for the lower amplitude, and the diagram 1 mark. And no negative marking there, colleagues, please. And then 642, the one that is going to have a high pitch, it is going to be diagram number 2. Why? It is because it is having a higher frequency, for 2 marks as a reason. And then 6.5, explain the term ultrasound. So for ultrasound, we are saying it is wave with frequency greater than 20,000 hertz. We are going to accept if a learner is putting it as a frequency greater than 20 kilohertz. We are going to accept it for 2 marks. And then next question, name 2 uses of ultrasound in technology. So we are having a range there. It can be used to detect the object, to measure the distance, determine the heartbeat of a fetus, measure the speed of blood to detect the narrowing of blood vessels, determine the sex of the fetus, and then also used in bone osmometry or bone fragility, and then treatment of soft tissue ailments. Any of the 2, and any which are not mentioned there, but which you know are in the textbooks and then are acceptable. No questions for question number 6, I hope. I don't see any. Let's move to question number 7. Question number 7, it is all about magnetism. It says a learner in a technical sciences class pick up a bar magnet like the one shown below. 7.1, define the term magnetic field. Magnetic field, it is a region in space where another magnet or a ferromagnetic material will experience a force. 2 marks for that definition. And then 7.2, draw the magnetic field pattern around a bar magnet. So in the memo, the shape, it should be the way it is, the way we are looking at it. So bent in the middle, and then also curved at the extreme, at their ends there. And then also, please, colleagues, check that the direction is correct from north to south, and then that lines are not crossing for the learner to get hold of the 3 marks. If any of the mentioned ones in the criteria, it is not fulfilled, then that learner will be penalized for 1 mark there. And then let's go to 7.3. In 7.3, accidentally the bar magnet fell and broke into 2 pieces as shown below. Now there goes the 2 pieces and then the labels of the magnets. Now 7.31, is the force experienced by the magnets when they are brought closer together attraction or repulsion? For that one, it is going to be an attraction for 1 mark. And then 7.3.2, identify poles. Pole labeled 2. The pole labeled 2, it is going to be north, or we are going to accept N as a label there. 1 mark for that. And then 7.4, give 1 example of a phenomenon that is affected by the Earth's magnetic field. So it is the Earth's magnetic field. Now, then we are talking of the aurora borealis or the northern lights, or we are going to talk of the aurora australis or the southern lights, or we are also going to accept the magnetic storms. Those are the ones that are acceptable. The total for that question, it is 8 marks. Question number 8, it is still under electrostatics. It says the two oppositely charged point charges S and T are held 0.03 meters apart as shown in the diagram below. The charge on S is positive 7.2 multiplied by 10 to the power minus 9 coulombs, while the charge on T is unknown. The magnitude of the electrostatic force that T exerts on S, it is equivalent to 5.18 multiplied by 10 to the power minus 4 newtons. And then the picture, it is given, or the drawing. And then 8.11, state Coulomb's law in weights. Now for this one, it is going to be part marking. The attraction or repulsion force between 2 point charges is directly proportional to the product of the magnitude of the charges for 1 mark and inversely proportional to the square of the distance between the 2 charges, 2 marks, part marking. And then 8.1.2, calculate the magnitude of charge T. Now for this one, we apply Coulomb's law as it is. 1 mark for the formula, 1 mark for substitution for the force, 1 mark for substitution, the product of the magnitude, and then colleagues, please just instead of that X, we can also accept QT because the charge it is on T, not X. It is not labeled as X. So QT, if a learner wrote QT there, it's fine for us. Or an unknown. Some of the learners will just put it as an unknown because unknown can be X for them. So that's why we put an X also there. And then total for that, it is 4 marks. And then 8.13, draw the electric field pattern or lines due to the 2 charges. So here there was at least a guide that the pattern should be in lines. And then we accept it to be like that, the shape should be that one. So if the learners are giving it for the same, maybe charges positive or negative, then the shape it is going to be 0. And then the field lines, colleagues, if it is not this, actually that learner should be getting 0. Really. But being where we are, according to the marking criteria, we can maybe give that maybe lines are moving from positive to negative. I don't know, because if they are the same, then they're not going to go to any other. So still it is going to be 0. Maybe they will get 1 for lines not crossing, but really it should be 0 out of 3. But you'll see as you mark where maybe lines are not crossing, and then because it is Christmas and then learners have done maybe justice to this, then we'll look into that. But you'll see it as we proceed. 8.2, it says there, a negatively charged oil droplet of mass 4.8 multiplied by 10 to the power minus 15 kilograms is stationary at point A in the electric field between 2 oppositely charged parallel plates, which are 20 millimeters apart. The potential difference between the plates is 750 volts. And then it says the 8.21, explain why the charge is stationary at point A. So that is your oil droplet. Why is it stationary? The reason is the weight equals to the electrostatic force, or Fg, it is equal to Fe, 1 mark for that. And then number 2, 8 point, as we proceed, the charge is now moved to point B, where the distance between the plates, it is 25. So they just increase that 25 millimeters as shown. Calculate the charge on the oil droplets while stationary at point B. Option number 1. It is where we are using electric field equal to V all over D, or the potential difference divided by that. No mark for that formula. And then the substitution, we are having 750 divided by 25 multiplied by 10 to the power minus 3. So that conversion there, 1 mark for the substitution. And then carry it over to the other formula where E, it is equal to F divided by Q. Electric field, it is where a charge will experience a force, and then the force can either be 1, but we are not having the electric field, is not given. The force due to electric field is not given. We are given the mass of that object, and then the G, it is there. So based on what was asked in the first question, then this is a follow-up divided by Q. So taking the electric field calculated, 1 mark for that answer, and then substitution of the mass and multiply by G to can calculate the Q, another mark there. So 1 mark for the formula leading to the answer, and then 2 marks, in fact 3 marks on the substitutions, and then the final answer going to 5 marks. Option number 2. The learner can just look at that and put it together, that FE, it is equal to FG, and then just substitute FE equal to EQ, and then FG equal to MG, and then waiting for the Q. So any formula that the learners have given there, 1 mark for that. And then on the left-hand side, on the substitution, we are having 750 multiplied by Q divided by that. Why 2 marks? If we look on the left-hand side, that 750 divided by 25 is the same as what it is in option number 1. And then the very same part, you see, we are going to get that 3.4, and then we are multiplied it by Q. So whatever we have, we are going to multiply it by 2 if we are doing a cross multiplication. So it is the same for that 3.4, 3 multiplied by 10 to the power 4 multiplied by Q if you cross multiply. And then the other mark, it is exactly like it is on the left-hand side. So that is why we are having the 2 marks on that substitution on the left-hand side, and then 1 mark on the substitution on the right-hand side, and the final answer for us to go to 5 marks. Total for that, it is 15. That is question number 8. In the absence of any, we go to question number 9, which is on electric circuits and happen to be the last question. It says there, in the circuit below, the battery has an unknown EMF and a negligible internal resistance. The ammeter and the connecting wires have a negligible resistance. The voltmeter has a very high resistance. And then when switch S is closed, the voltmeter V1 registers a reading of 6 volts. So that V1 is only across the 3 ohm resistor there. And then this registering a 6 volts. 9.1. Define the term EMF of a battery. So that is the potential difference across the cell when the circuit is open. So part marking there for 2 marks. And then 9.2, calculate the current through each of the 3 ohm resistor. So we are having 3 there, but they are in series, so the current is going to be the same for any one of them. So that will be equaling to V equaling to IR or Ohm's law, the way they can put it. So the resistance we have, it is 3, and then the voltage across there, it is 6, and then we can calculate the current to go to only 2 amperes for 3 marks. And then 9.3, the total resistance of the circuit, it is 8 ohms. Now, question number 3, 9.3 says, calculate the resistance of R. Now, R, it is connected in series, and then we're having that branch, which is a parallel. So we start first with the one of the parallel, which is 1 over R parallel equaling to 1 over R1 plus 1 over R2. And then we substitute the ones that are parallel, it is the 12, and then the sum of the 2, which is going to be 3 plus 3. And then the parallel combination, it gives us 4. And then for the total, we are given that it is equaling to 8. So that total, it is for the parallel and the series. And then when we calculate that R, then it is going to give us R, it is equaling to 4 ohm resistors. For the formula, colleagues, and the substitution on the parallel, we are going to accept the product sum equation and then the substitution thereof. It is still going to give us the parallel to be equal into 4. And then from there, it is the same. So total for that question, then it is going to be equal into 5 marks there. And then 9.4, calculate the reading on the ammeter A. So that ammeter A, where it is placed where it is going to read the total current in that circuit. So for option number 1, we can first calculate the current through the parallel. So in the parallel, we apply Ohm's law. V across the parallel, it is the same. So in the 3 ohm, we're having the 6. And then in the other one, it is going to be another 6. So for the parallel, it is going to give us that 12 there. And then the total in that, it is going to be equaling to 4 across the parallel, and we end up with the current of 3 amperes. That is option number 1. Option number 2, we can calculate the current across the 12 ohm resistor. Already we have calculated the current in the in each of the 3 ohm resistor. So we can calculate the one in 12. So the potential difference across the parallel is the same. It is going to be 12, and the resistance given there it is 12. So we end up with the current passing through the 12 ohm resistor S1, and then the total current in that branch across the parallel, then it is going to be equaling to 1 plus 2, which is going to be equaling to 3 amperes for 4 marks. Question number 5. It says they calculate the EMF of the battery. So the EMF, we can use it as equaling to the total voltage in that. So we have calculated the total current. We know the total resistance of that. So it is going to be equaling to 3 multiplied by 8. And then it is going to give us 24 volts. Or alternatively, we can say the EMF, it is equaling to V across the parallel and V across the series combination. So the total current passing through the series, it is 3, and then we have calculated that that resistance to be 4. So it is going to be 12 plus 12 across the parallel, it is 12, and then give us the total of 24 volts. 9.6. Draw a sketch graph for a potential difference against current for an ohmic conductor. Now, in our circuits that we are using, our conducting wires and any other component that we are using, unless otherwise stated, it is obeying Ohm's law. So hence this question, and then that is what we are expecting there. 9.6, then the 2 marks, the labels be correct, and then the shape of the graph passing through the origin there. It's an ohmic conductor, then it should be directly proportional. And then 9.7, it says that when switch S is open, state whether the reading on voltmeter V1 will increase, decrease, or remains the same. So when you open that switch S1, there will be no current flowing through that 12 ohm resistor. So we are only going to have a series combination. Because of that, now 1 mark, it is going to be saying that the total resistance in the circuit, it is going to increase. And as that resistance, it is increasing, the total current, it is going to decrease. Now, because of that, according to Ohm's law, V is that proportional to I for another mark. Then we can draw a conclusion, therefore, that then that reading on V1, it should be decreasing because the current, it is decreasing, resistance is the same. So that is the reason why we are ending up with that. And colleagues, this is a type of a question that we'll always get. But starting with increase, decrease, our learners must learn that increase, decrease is a conclusion. So they must end up with it, come up with the reasoning, and then go for the conclusion as what it is expected of them. The total for that question, it is 23, and then the grand total for this question paper, it is 150 marks. That brings me to the end, unless if there are some other issues that need to be clarified and then be explained.
Thank you very much, Ntate Ntsiye, for a lovely presentation. I do not see any hands or comments. It says colleagues are very happy with the marking guideline as how it is outlined. Just a quick reminder, colleagues, kindly complete the register. The recording is already currently available on YouTube for those maybe that did not manage to be here. And with that being said, ladies and gentlemen, thank you very much for all the hard work you've been putting in to assist our grade 10 and 11 learners. So I hope we'll do the same and prepare them now for paper 2. With that being said, ladies and gentlemen, thank you once more for your time, and may the great Lord bless you. Thank you very much and have a lovely day.
Thank you, Ntate Nambani, and good night, colleagues.